Welcome everybody. It's Ramchandra from CIVIL-MECH-MATHS Concepts. In the lecture Structural Analysis 12, I have discussed about the bending stresses in the beams, and in which I have taken a very long problem numerical, in which first part we have found out the allowable maximum bending stress in the structure. Now, we have to design a cantilever beam by taking that stress into consideration, and we have to find out the beam vibrations. In the last class I have told that I will be starting the beam vibrations from this class onwards. It is structural analysis 13. In this I have taken up beam vibrations. It's a very important topic, not only for civil engineering, it is for civil and mechanical engineering also. This is an advanced topic and very important topic. There can be objective type questions for SSC JE and also GATE. There can be subjective questions, descriptive questions for UPSC Engineering Services Examination for both civil and mechanical engineering on the beam vibrations. It's a very important topic. And beam vibrations, what is the reason for a beam to vibrate? A beam vibrates under the application of a load. And especially in this lecture, I have taken up cantilever beam, for which the equation is given as the natural frequency is omega, and the equation is omega square is equal to 3 EI by P plus 33 by 140 m L cube, where m is the self weight of the beam, E is the Young's modulus of the material, I is the second moment of area of cross section, and P is the applied load. This is the self load M. L is the length of the cantilever beam. It will be like this. This is P. This is the length of the beam L, and M is the self load and P is the applied load. And E and I are, E is Young's modulus from the property of the material of which the beam is made, and I is the second moment of area from the cross section, or moment of inertia we can call. Now the equation is omega square is equal to 3I by P plus 33 by 140 m L cube. Till now we have come across the beams and their analysis by neglecting the self weight of the beam. In this we are taking the self weight also. We are going to apply the general formula. We will try to learn the general formula. From that, if we neglect the self weight, we will make small m as 0. Then we will find out the equation. In this, I am not going to derive the equations. I will give the concept, and once you understand the concept for cantilever beam, then we will try to apply in the next class to simply supported beams and different types of beams. Now we will go with the cantilever beam. A cantilever beam is the beam which is fixed at one end and free at other end, and if a point load P is applied at the free end of the cantilever beam of length L, and M is equal to self weight, P is equal to applied load, both are in same units. self weight, or we can say self mass. Let it be in kg, applied load also in kg. If it is in tons, let it be in tons. Let us convert everything into SI units. In SI units, it is kg. Instead of self weight, we can even call it as self mass. Don't worry about the. As long as both are in same units, don't worry about the jargon of verbs or words. Self mass, kg, and applied load. And what happens when a beam, like a cantilever beam, is subjected to a load? What happens to it is, at a free end, this is the original beam, this is P, and it bends like this. This is the bending, deflection. This is the bending. And a distance of x measured from fixed end, let the deflection be y, and let this deflection be y max. The maximum deflection or the maximum bending takes place at free end. At fixed end, I have already told you in the previous classes, all the three are constants. There will not be any bend, any deflection there. There will be horizontal resistance, vertical resistance, and bending moment resistance. All the three are restrained. At free end, this y max is the deflection, let us say the deflected part. And what is the shape of this deflected part? This is more important. Shape of the deflected part. I will give the equation. The shape of the deflected part is y is equal to y max into 1 minus cos pi by 2 into x by L. This is very important formula. You please remember, in the form of it's rather we can say it is a polar form, in the form of angle. It is in the form of angle. Y is equal to y max into 1 minus cos pi by 2 into x by L. If x is equal to L, if x is equal to L, that means x is extended to L, what happens? Y is equal to y max into 1 minus cos pi by 2 into L by L. What is L by L? That is 1. That means that is equal to y max into 1 minus cos pi by 2. What is the value of cos pi by 2? That is 0. That is equal to y max. That means this equation satisfied the boundary condition at one end, at x is equal to L. If x is equal to 0, what happens? Y is equal to, it is x is equal to L. X is equal to 0, what happens? Y max into 1 minus cos pi by 2 into x is 0, 0 by L. That is equal to y max into 1 minus cos 0. What is the value of cos 0? That is 1. 1 minus 1 is 0. That means this is equal to 0. That means the above equation y is equal to y max into 1 minus cos pi by 2 into x by L satisfies both the boundary conditions. At fixed end, deflection y is equal to 0. At free end, y is equal to y max. This can be one of the objective type questions. If a load P is applied at a free end of a cantilever beam, at the free end the maximum deflection takes place, at the fixed end the deflection will be 0. Very important concept we have developed now. Now next, by using this, why? You remember beam theory. What is the equation of beam theory? Beam theory is equal to, beam theory implies m by I is equal to sigma by y is equal to E by R. Which implies m is equal to E I by R. Do you agree to it? Please go back to your prelims which I have taught you in EI by R. But 1 by R is equal to d theta by dx. That also I have explained you in my previous lectures. Because theta is very small, this we have treated as d by dx of dy by dx, that is equal to d square y by dx square. This can also be an objective type question that can be asked either in GATE or SSC JE. The inverse of the radius of curvature is equal to d square y by dx square. Very, very important derivation. One by one we are deriving important equations. Please remember them. By using the beam theory equation and this equation, what happens to this? M is equal to EI by R. M is equal to EI by R. You just see. What is 1 by R? D square y by dx square. That means M is equal to EI into d square y by dx square. This is a very, very important derivation. It's being used almost in all the places for finding the deflections, for finding the differential equation. It is a differential equation. Y is the deflection, x is the length, just see, this is the cantilever beam. In this, it is the x, and this is the deflector shape, and at any point x, this is the y. The relation between bending moment m and deflection is m is equal to ei into d square y by dx square. Very important equation. All equations are very important in this lecture. Next, what is m by r then? We have found out m. What is m by r? M by r is equal to, this is also very important, m into 1 by r. What is 1 by r? D square y by dx square. That means m is ei into d square y by dx square. That means d square y by into d square y by dx square. That implies m by r is equal to ei into d square y by dx square whole square. This is another important equation. The relation between the moment and the ratio of moment to radius of curvature is equal to ei into d square y by dx square whole square. This is the ratio of bending moment by radius of curvature. Question will be, what is the value of ratio of bending moment to the radius of curvature? Then that will be ei into another question. Question has come. Now answer is also ready with you. This is the answer. Ei into d square y by dx square whole square. And next, whenever vibrations take place in physical system or in a mechanical system or in an engineering system, whether it is civil engineering or mechanical engineering, the equation is, I am not going to derive the equation. Please remember this equation, very, very important equation. Because in GATE examination or SSC JE, derivations may not be there, but even in UPSC examinations, if the derivation is asked, please refer to the standard textbooks. I am not going to derive it. I will write the equation, very important equation. Omega square is equal to integral ei d square y by dx square whole square dx whole divided by integral y square dm, where m is the mass of the beam. Small m is the mass of the beam. dm is the small m. Integration will give the, this is nothing but, this is mass into distance square. I is second moment of area. This is the mass moment of area. Please understand. This is mass moment of area. Mass moment of area. This is second moment of area. Now, omega square is equal to integral ei d square y by dx square whole square dx whole divided by integral y square dm. This is the natural frequency. This is the equation for the natural frequency. Omega square is equal to integral ei d square y by dx square dx whole divided by integral y square dm. This is the standard equation where I have defined m and also I have defined y and I have defined x also, and e and I also I defined. From this equation, by applying y is equal to y max into 1 minus cos pi by 2 into x by L, we can find out d square y by dx square, and we can substitute this d square y by dx square in the previous equation, that is omega square is equal to integral ei d square y by dx square dx, and this y also you can substitute in integral y square dm, and finally we get a value of, for a cantilever with self mass of m applied a mass p at free end, we get omega square is equal to three ei by p plus 33 by 140 into m into L cube. This is the very important equation as far as the natural frequency of the cantilever beam of self weight m and load p is concerned. Now